be Bhumika. I am studying 8th class. I am from TTWR Girls Vaira, Khammam. Today I would like to explain one topic, but I won't say the topic name. I just give some clues to you. Like, once upon a time, there was a thick forest. In that, one tiger is living. The tiger daily eats the animal and kills the animal. But one day, there is no animal to eat. The tiger is searching, but there is no animal. Suddenly, one animal is run in front of the tiger. The tiger is running to catch the animal and eat the animal. So, the tiger is run. What tiger is applied there? The tiger is applied there force. So, my theme is about force. The introduction of the force is first about my topic. Objectives are force and about types of forces. And the introduction of force is pulling, pushing, and both it changes the state of motion and the shape of motion. First one is pulling. In our daily life, we observe that when the fruit is ripe on the tree, then it is fall down. Means the earth doing fruit towards itself, called as pulling. And another example, we take one magnet and some pins and take one board. Keep the magnet nearby pins. When we can keep near the pins, the magnet can attracting the pins. Means magnet doing pins towards itself. The pulling is nothing but the force applied to make object towards ourselves, called as pulling. And next one is pushing. When we can close the door, means I am doing door away from myself, called as pushing. And another example is we take when we are traveling on the road, for example in a car, then engine want to give energy to the car to move. Means engine is pushing the energy to the car. The pushing is nothing but the force applied to make object away from ourselves, called as pushing. And force can change the state of motion and the shape of motion. First one is state of motion. You can assume that you are traveling on the road. For example, in a car, then the car, in front of the car, so many people are going other places, are buying vegetables or fruits. Then we want to decrease the speed and change the direction. The state of motion is nothing but increasing, decreasing, fast, slow, called as state of motion. And next one is shape of motion. We take an example, a duster. The shape of the duster is cuboid. When I press the duster, the shape is changed. And another example is, we take one ball. The shape of the ball is sphere. When I press the ball, the shape is changed. And another example is, we take rubber band. The shape of the rubber is circle. When I touch the rubber, the shape is changed. In olden days, there is no any metallic object, so they used the soil to make the object like this with the help of their hands. So they applied their force. We can understand that force can change the state of motion and the shape of motion. How could we can say force is a pushing or pulling? When we can ride a bicycle, most of the times our legs are pushing down the pedals. To push, we have to make an effort. When we pick up our school bag, we have to make an effort in order to lift or pull the bag upward and off the ground. Actions like throwing the ball, stretching the rubber band, and lifting any object. These are actions involving terms of pushing or pulling are digging, sucking, arising, rubbing, attracting, etc. Effects like digging the borewell, Here we are involving both pushing and pulling. So it is both. Sucking the juice with a straw, I am doing the juice towards myself, means I am taking the juice in my body. It is example for the pulling. And erasing the board with a duster, I am doing pushing. And a magnet attracts the nails. Here a magnet can attract the pins. Magnet is doing pins towards itself. It is called as pulling. Based on all things, we can explain that force is a pulling or pushing or both. And there are so many types of forces, but there are two main types of forces are contact force and non-contact force. First one is contact force. An example, we take one brush and toothpaste. When we can press the toothpaste, then paste come out. There is an attachment between my hand and toothpaste. This attachment is nothing but contact force. Here in this picture we can see there is an attachment between here brush and toothpaste. Is also example for contact force. When we can do any work or when we can take any object, when we can throw any object, there is also a contact force. The contact force is nothing but the force results when there is a direct physical contact between two objects is known as contact force. In contact force, there are three main types of forces are muscular force, frictional force, normal force, and another force is also in contact force, that is nothing but tension. Here first one is muscular force. In our villages we observe that when the farmers are cultivating the crops with the help of their hands, when we can jump, when we can run, when we can do exercise, when we can dance, and in our daily life we observe that so many people are climbing the rock. Then also their body is moved. When our body is moved, automatically our body muscles are moved. The movement of body muscles is nothing but here muscular force. The force that is exerted on our body muscles is known as muscular force. And next one is frictional force. Roll a ball on the floor. When we are rolling the ball, after some times it will be going to in a rest state. Why? Because another force acting to reduce its speed is nothing but friction. Here changes of speed is depend on roughness and smoothness of a surface. An example, here when we can throw a ball on the floor, after some times it will be going to in a rest state. When we can roll same ball on the carpet compared to first one, in a short time it will be going to in a rest state. Why? Because carpet is rough surface compared to the floor. Friction is resistance of the movement of a body over the surface of another body. Force opposes the relative motion of two surfaces of bodies in contact is nothing but frictional force. And next one is normal force. Place the textbook on the table. When the book is on the table, it is in a rest state. What forces are acting on the book? We can assume that by magic the book is fall down. What will happen? The book is fall down. What will happen? When the book is on the table, then also the gravitational pull is present, but it does not fall down because there is a support of the table to the book. The force exit which supported a book against gravity is nothing but normal force. The force that is a solid surface exerted on normal direction is called as normal force. Here, normal direction is nothing but which a force perpendicular to the plane of surface is called as normal direction. And next one is tension. Take a stone is tied with a string. Free ends are tied with a rod. Note what forces are acting on the stone. You can assume that by magic the string is broken. What will happen? The stone is fall down due to the gravitational pull of the earth. But when the stone is tied with a string, then also gravitational pull is present, but it does not fall down. Why? Because there is support of the string to the stone. The force exit which supported a stone against gravity is nothing but tension. The feeling tightness of a rope or a string is called as tension. And another force is nothing but, here first one is contact force and next one is nothing but non-contact force. Take a magnet and take a cardboard and keep the pins upon the board. When we keep the magnet nearby pins, the magnet will attract the pins. Without contact, the magnet is attracting the pins due to the non-contact force. The non-contact force is also known as field force. Here, in non-contact force is nothing but the force which occurs without any physical contact between two objects is known as non-contact force. In non-contact force, there are three main types of forces are magnetic force, electrostatic force and gravitational force. First one is magnetic force. Take a magnet and some pins. Take a white thick paper. Keep the pins upon the paper and keep the magnet down of the paper. When we can move the magnet, along with magnet, the pins also move. Without contact, the pins are moving along with magnet due to the magnetic force. Here, a magnet will attract like poles. Here, when we can attach like poles, they will be repulse each other. See, these are not attracting each other. When we can attach unlike poles, they will be attract each other like this. This is nothing but due to the magnetic force. Here, a magnet will attract or repulse by another magnet without contact. So, magnetic force is also known as field force. Visualizing magnetic field. Visualizing magnetic field. Next, we take one bar magnet, place it on the table and take a thick white paper, place over it. On the paper, sprinkle fine powder of iron. Here, when I sprinkle the magnet, the fine powders can create a new thing once observe it, and tap the table or magnet with the help of pen or pencil. See here, the like poles and unlike poles taken more fine powder of iron. Rotate the magnet in different directions and tap the table or paper gently with pen or pencil. See that in a small space around the magnet, the iron filling set themselves a pattern because they are affected by the magnetic force of the field and created a bar magnet. The pattern represents the magnetic field, and the space around the magnet where it influences and be detected is nothing but magnetic field. And the strength of a field in a particular region where it is represented in field lines. The greater the density of lines, the stronger the forces in the part of the field. The magnet attracts the magnetic materials such as iron, but either the attract or repulse by another magnet is nothing but magnetic force. And next one is electrostatic force. Take a balloon, fill the balloon with air and take some piece of papers, cut into beads and take the balloon, rub the balloon with the help of cover. When we can rub the balloon with the help of cover, the balloon will attract the piece of beads. Once observe it. When I rub it produces heat and the balloon can attract the piece of beads. Once observe it. See here, the balloon is attracted piece of beads. Here, the balloon is attracted piece of beads. The balloon is, when it's charged with a cover, it requires the electrostatic charges, and when we keep nearby piece of beads, it requires the opposite charge and they attract each other. And another example, we take one refill and rub the refill with the help of paper. And rub the refill with the help of paper. When we can rub the refill and take one paper and cut into piece of beads, when we keep the refill nearby piece of beads, the refill can attract the piece of beads. Once observe it. Here, the refill can produce the heat and it attracts the piece of beads. See here, the refill is attracted the piece of beads. And another example is, we take one comb and rub the comb with the help of our hair and take one paper and cut into piece of beads. When we can rub the comb with the help of our hair, the comb will attract the piece of beads. Once observe it. See here, the comb is attracted the piece of beads. The electrostatic force is nothing but charged body on another charged body is known as electrostatic force. And next one is gravitational force. It is our common experience. When a pen or pencil slip off from our hands, it will be fall down. If we keep the same pen on the table or any book, it does not fall down. Why? Because there is a support of the book to the pencil. When we can throw any object upward, it exerts a force which pull down towards the earth is nothing but gravitational force. Here, everyone on the earth can closer to the gravitational force. And the force of gravity is not just due to the attraction of the earth. It exists between any two massive objects. An example, when we can sit in our classroom, the force exists between the teacher and the student, the board and the student, but it does not visible because the force exerted by earth and the force exerted by teacher and the student, board and the student, it is very less. The earth can hold the atmosphere because the earth has the more gravitational force. And next one is net force. Next one is net force. Push a heavy wooden table. The table does not move because it will want more force. So the first person asks second person come oppositely and pull the table. The table will be moved because first person exerted force and second person exerted force. the force will be more and the table will be move. But when the first person said, second person come oppositely and push the table. But table does not move. The both peoples have equal forces. We can assume that first person has more force and second person has less force. Then first person can push in the side of second person. All forces have both magnitude and same direction. But which force along a straight line and same direction, the net force is taken as sum of all forces acting on an object. To add forces, sign convention must be used. F1 directed towards the right, so it is taken as positive. F2 towards the left, so it is taken as negative. F1 and F2 both are on the table oppositely. So F net is equal to force 1 minus force 2. And another example, we take one rubber. Stretch the rubber with the help of our fingers. It requires less force to stretch. We take another rubber. It requires some more force to stretch the rubber. We can take more and more 3 rubbers. It requires some more force to stretch the rubber and take 5 rubbers. When we can stretch the rubber band, it does not move because we want to use here more and much and force. Here the free body diagram. How to calculate the free body diagram? What forces are acting on the object? An example, we take one car. What forces are acting? Here, front of the car, engine force. Is the engine force applied is equal to engine force. Oppositely, engine force, the force applied by the road is friction. And when the car is in a rest position, the force is that is normal 1 and normal 2. And the force applied by the earth is nothing but gravitational force. The net force along a x-axis or direction is taken as F1 minus friction minus force. Net force along a y-axis or direction, the F net y is taken as normal 1 plus normal 2 minus gravitational force. And in this lesson, we learn that forces, the force is nothing but pulling, pushing and both. It changes the state of motion and the shape of motion. In forces, there are 2 main types of forces, are contact force and non-contact force. In contact force, there are 4 main types of forces, are muscular force, frictional force, normal force and tension. And next one is non-contact force. In non-contact force, there are 3 main types of forces, are magnetic force, electrostatic force and gravitational force. In that, the another one is net force. And next one, we observe that free body diagram. Lastly, I conclude that in our daily life, without force, we can't live. All things are interlinked with the force. An example, when we can jump, when we can run, when we can walk, when we can throw any object, an example, and other things. Here, all things were applied their force. So lastly, I conclude that without force, we can't do anything. Thank you one and all. I thankful for the Secretary Sir and society, and I thankful for our Principal Ma'am, Nagendra Ma'am, and my guide teacher, P. Rajni Ma'am. Thank you for one and all.